Dr. Judah Folkman began his career as a surgeon. He developed an idea about how cancers grow inside the body. This idea had to do with angiogenesis, the formation of new blood vessels. It was not popular among his colleagues.
I had seen and handled cancers, and they were hot and red and bloody. And so when critics would say, well, we don't see any blood vessels in these tumors, I knew they were looking at tumors that had been taken out. All the blood was drained. They were specimens.
Dr. Folkman thought there must be a chemical in the tumors that caused the blood vessels to grow. If he could identify it, this would add to our understanding of how cancers develop. But his fellow researchers were doubtful.
He came on the scene when molecular biology was just going, and if you weren't working in a cell, working on a chromosome, or scratching a gene, you really weren't in the mainstream of bench research. And I think, they thought, well, what's he talking about, blood vessels?
To prove his theory, Dr. Folkman designed an experiment. He would need to show that tumors can create blood vessels in a tissue that usually never has blood vessels. He decided to use a cornea, the transparent part that surrounds the eye, because blood vessels normally never grow there. With his colleague, Dr. Folkman inserted a tiny piece of tumor into a rabbit cornea and waited. After a few days, blood vessels emerged and headed straight toward the tumor like a bullseye.
Blood vessels would shoot in, and when they got to the tumor cells would grow around, and suddenly this big tumor would grow in 2 weeks. It would grow 16,000 times its original size.
When they removed the tumor, the blood vessels would disappear. But for his fellow researchers, this wasn't enough proof.
If you say, I found angiogenesis, your scientific colleagues are saying, what's the mechanism? Well, part of the answer to what's the mechanism of angiogenesis, of tumor angiogenesis, is what factor is the tumor making that brings in those blood vessels?
So, Yuan Ching and Michael Klagsbrun, two researchers in Dr. Folkman's department, set out to find this factor, a mysterious chemical that brought about blood vessel growth. To do this, they needed to isolate a molecule from the tumor tissue and see if that molecule alone could cause angiogenesis in the rabbit cornea.
Well, the body has thousands and thousands of proteins, and the challenge was to be able to separate one molecule out of these thousands.
To separate and purify molecules, scientists use glass columns packed with substances that attract certain molecules and that let others pass through. They then use a solution to collect the bound molecules.
So you have this column, you throw your tissue extract over that, and then you watch the material come out of the column drop by drop. The big proteins come out first, the little proteins get stuck and they come out later. The tiniest proteins come out the latest.
For years, they did not have much success. They separated molecules by every property they could think of: size, weight, positive and negative charges, affinity for other molecules. But none of the molecules they collected caused any blood vessels to grow in the rabbit cornea.
In research, there's a very fine line between persistence and obstinacy. You do not know whether if you're persistent a little while longer, you'll make it, or whether you're just being obstinate, it doesn't exist, and of course you can keep on going and stay with an idea too long, called pig-headedness.
Then, one day, they tried a column that was packed with a substance called heparin. They placed the protein they collected from this column into a slow-release pellet and placed the pellet in the cornea. Soon after, blood vessels rushed in. They had found it.
Almost overnight, many critics were transformed to competitors because people began to see that there was a molecule in this field. That was the first. There are now 17.
And Dr. Folkman did not stop there. He realized that if tumors call on blood vessels to get nutrients and grow, then finding a molecule that stops the growth of blood vessels could have tremendous applications for cancer treatment.